In this lesson, we will learn how to construct and understand equations for chemical reactions. We will also learn to write chemical reactions using both words and chemical symbols. Learning to understand chemical reaction equations can be a bit like learning a new language. Our equations involve words and symbols that might not always be familiar. So let's review some of the key features that you might come across when looking at reaction equations. You may see reaction equations written in the form a bit like this, where you have one or more substances on the left, in this case two substances, A and B, some kind of arrow, and then some more substances, or just one substance, on the right-hand side. Let's look more closely at some of these features. All of the substances to the left of our arrow are referred to as reactants. These are the substances which go on to react in our equation. On the right-hand side of our arrow, we have the products. Notice that we may not have the same number of reactants as we do products, and vice versa. Now let's take a closer look at our reaction arrow. The arrow drawn here is perhaps the most common sort of reaction arrow that you might come across. It denotes that the reactants become the products. You may also come across the equilibrium arrow, which looks like this. This denotes that the reactants are becoming the products, but also the reverse reaction may be taking place as well, where the products turn back into the reactants. You may also see it drawn where the two arrows are not the same size. We won't go into understanding these right now, but just know that they are similar equilibrium arrows. We also have this plus symbol in our reaction equation, which is used to separate different chemical species. You may see this on the reactant side and on the product side. Sometimes you may also see text or symbols drawn above the reaction arrow. This gives us extra information about the reaction. For example, we might find a symbol for heat here, or even a specific reaction condition, such as a specific temperature, or perhaps the presence of a catalyst. These are things which are needed for the reaction to occur, but are not themselves reactants or products. Something else you might come across are state symbols. These are written in brackets and as a subscript to our products or reactants. The state symbols you're likely to come across are S for solid, L for liquid, G for gas, and AQ for aqueous, meaning dissolved in water. These state symbols tell you which physical state each of our species is in at the time. Water is a great example for understanding some of these state symbols. H2O, with the gas state symbol, is of course steam. H2O with the liquid symbol is liquid water. And H2O with the solid state symbol is of course ice. You can see from these examples why it might be important to include a state symbol in some cases. HCl is another good example, where HCl aqueous is hydrochloric acid, but HCl gas is hydrogen chloride gas, a very different reactant or product. So this is why you might see state symbols included in your reaction equation. Now that we've looked at some of the general features of our equations, let's study some examples. Let's begin by looking at two simple reaction equations. On the left of our arrow, we have the reactants, and on the right, we have our products. Let's have a look now at how we might read these equations out loud. You can start by just reading sodium plus chlorine, but how do we say this reaction arrow in words? It turns out there are lots of different options, but we'll just go through a few. The most common way to say this reaction arrow is react to form, as in sodium plus chlorine react to form sodium chloride. You can also have similar phrasing such as react to make, or just the word form, like sodium plus chlorine form sodium chloride. But what about in our second example? In this example, we only have one reactant to the left of our arrow. So we can't really use the word react when talking about our arrow. React implies that you have more than one substance. So when reading this kind of equation, you could use the word decomposes or yields. So you could say calcium carbonate decomposes to form calcium oxide plus carbon dioxide. If you ever get stuck trying to understand a reaction equation, particularly one with symbols, it can help to try to read it out loud, or at least read it through in your head. This can be helpful when writing your own reaction equations, for example. Let's look at how to do that now. You might need to write out a reaction equation from an experiment that you're doing. Let's try writing our own reaction equation from this experimental detail. Potassium hydroxide reacts with sulfuric acid. Potassium sulfate and water are formed in the reaction. So where do we start? Let's begin by identifying what our reactants are. Remember, the reactants are on the left of our reaction arrow. We can see the word react in our first sentence. And we're told that potassium hydroxide reacts with sulfuric acid. So here we have two reactants. We can write these out with a plus symbol in between to start our reaction equation. Now that we've found all of our reactants, we can add in our reaction arrow. We aren't told that this reaction is in equilibrium with anything, so we can draw a normal reaction arrow. Next, we need to find our products. In the second sentence, we're told what is formed in our reaction, so these must be our products. Let's add potassium sulfate and water to the product side of our reaction. Now that we've added our products, our reaction equation appears complete. To check that we've done it right, we can try reading it aloud and comparing it with the information from the experiment that we've been given. Potassium hydroxide plus sulfuric acid react to form potassium sulfate and water. This appears to match our experimental detail, so must be correct. You might be asked to write your chemical equation using chemical symbols instead of words. Here, all we need to do is to convert our word equation into chemical symbols. Let's do this one item at a time. Let's start with our first reactant, potassium hydroxide. We know from the periodic table that the symbol for potassium is K. Now we just have to remember the symbol for hydroxide. Luckily, the clue is in the name. The first part, hydr, means we have a hydrogen, and oxide means we have an oxygen. You may remember that potassium hydroxide is KOH. If you hadn't remembered, you could work it out by looking at the ion that potassium forms, K+, and remembering that hydroxide is OH-, so together they form KOH. The plus in our equation stays the same, so next we need to convert sulfuric acid into the chemical symbol form. Sulfuric acid is of course H2SO4. Again, if we want to think about the ion forms, hydrogen of course tends to form H+, so SO4 must have a charge of 2- to balance out our two hydrogens. Our reaction arrow stays the same, so now we're on to the products, potassium sulfate and water. We already know that potassium is K and sulfate is SO4. We can use the charges on the ions to work out what the formula is for potassium sulfate. Because our sulfate has a charge of 2-, we're going to need 2 potassium cations to balance the charge. So potassium sulfate is K2SO4. Finally, we have water, which is H2O. So here we've written a reaction equation from experimental detail and then converted that word equation into a chemical symbol equation. Let's try a few more for practice. An experiment shows that hydrogen peroxide decomposes to form water and oxygen gas. Which of the following word equations describes the chemical reaction that has occurred in this experiment? A. Hydrogen peroxide decomposes to form water plus oxygen. B. Hydrogen peroxide plus oxygen react to form water. C. Hydrogen peroxide decomposes to form peroxide plus hydrogen. D. Hydrogen peroxide decomposes to form hydrogen and oxygen peroxide. Or E. Hydrogen peroxide plus water react to form oxygen. This question is asking us to form a word equation from the experimental detail given. Let's start by finding our reactants. Reactants are always on the left-hand side of our reaction arrow. In this case, we only have one reactant, since only one substance is listed, and we have the phrase decomposes to form. Decomposes means that one substance breaks down into one or more other substances. So here we have the beginning of our reaction equation. Hydrogen peroxide decomposes to form something. Now let's look for the products. The question tells us that the products are water and oxygen gas, so these should be written on the right of our reaction arrow. So here we've written the reaction equation from the details given to us in the experiment. Now we just have to match it with one of our potential answers. We can see that the correct matching answer is A. Remember that the order of the reactants or the product makes no difference. When aqueous silver nitrate is mixed with aqueous sodium chloride, a white solid precipitate of silver chloride is produced. The symbol equation for this reaction is shown below. AgNO3 blank plus NaCl blank react to form AgCl blank plus NaNO3 blank. Which state symbols should be added to each compound to complete the equation? This question is asking us to add state symbols to a reaction equation. So let's remind ourselves what we mean by state symbols. State symbols tell us which physical state a substance is in at the time. We use the letter S for solid, the letter L for liquid, G for gas, and AQ for aqueous, meaning dissolved in water. We are given our chemical reaction equation in the chemical symbol form, but our experimental detail uses the full word names for various compounds. To match these up, let's convert our chemical symbol equation into a word equation to make life easier. Our periodic table tells us that silver is Ag. Our compound contains nitrogen and oxygen, so that must make it a nitrate. So here we have silver nitrate. Na is the symbol for sodium, and Cl the symbol for chlorine. So this gives us sodium chloride, the sort of thing you'd sprinkle on your fries. Next, we have silver and chlorine again. So this must be silver chloride. And finally, we have sodium again and nitrate, sodium nitrate. Next, we need to find each of these compounds in the experimental detail to work out which state it is in. Silver nitrate is first, and the question tells us that it is aqueous. Aqueous means dissolved in water, and the state symbol for aqueous is AQ. Next, we have sodium chloride. This is also listed as aqueous. Next, we're looking for the first product, silver chloride. The question tells us that this forms as a white solid precipitate, so this is a solid. So we use the letter S. But what about the sodium nitrate? It's not specifically listed. We know that sodium nitrate didn't precipitate as a solid, so it must have remained in solution as aqueous. So we can label this also as aqueous. So here we have our reaction equation, complete with state symbols. Let's summarise the key points. Reactants are written on the left of our arrow and products on the right. Our reaction arrow usually means react to form or sometimes decompose to form. The arrow can also show if our reaction is in a state of equilibrium. State symbols can be added to our equation to show the state that substances are in. Sometimes reaction equations are displayed with words and sometimes with chemical symbols.